Rockets over daytime, weren't they pathetic? Surely could have been, nah.
Yeah, but I thought it was a lot of rubbish.
Yeah, Dean had an idea. He says if you put Coca-Cola into the water rockets, the gas would make it burn.
We'll have to see what happens.
Let's do it.
Right, Scott, did you hear about Dean's idea, right?
Yeah, I think we should see how much fizz is in a bottle of Coke.
Okay, let's go.
Let's go.
Today we're going to see, we've got 7 Mentos, Imperial mints, and we're going to put the ruler over the top and drop them into the Coke to see how much fizz there is.
Well, I think there was a lot in that then.
Joe is holding a clinometer. When Joe pulls the trigger, it turns and tells us the angle of his arm. Joe is standing 15 metres away from the rocket.
What? In the box.
Bottles went too fast for us to use Joe's clinometer.
Instead, we used the camera and freeze frame to show how high each bottle went.
The first bottle in each pair was water and the second was Coke. On both occasions, the water was 25% higher, so Dean's theory hasn't worked.
But we had fun checking it out.
Why? Didn't.
It worked.
The force on the rocket up is linked to the weight of water pushing down.
In the Coke, some of the water space is filled with gas which is lighter.
Result? Less.
Downward thrust.
Hello, 7778 are investigating something that happened on November the 5th. Let's go in and find out.
Have you ever wondered how you put colour in your fireworks?
The colour comes from the metal when they burn.
It's just coaxial metal. Lithium, watch it.
This is Wackers, what have you got?
Copper.
This is Chad, what metal have you got?
Potassium.
My metal is sodium. That's how they put the colour in fireworks, but what about sparkles?
Thomas is sprinkling iron filings into the flame.
Joe's going to build his name out of a piece of touch paper.
Joe.
As always with fireworks, we'll finish with a bang.
before something goes wrong.
Too late.
Many animals go through courtship dances. A step by one animal triggers its partner to respond. In some cases, these dances keep the pair together. This can be important if rearing the young takes the effort of two parents and is commonest in animals like birds and mammals. Albatrosses have a dance which leads to mating and makes them a long-term pair.
Both albatrosses stretch their necks, then bare their heads. They stretch towards each other and nibble beaks. The male walks round the female, always facing her. Both stand with wings out. The next step is mating.
I am the sun and I am the star.
I am Mercury.
I am Venus.
I am the Earth and the Moon.
I am Mars.
I am Jupiter.
I am Saturn.
I'm Uranus.
I'm Neptune.
I'm Pluto.
I'm a comet.
A year for a planet is how long it takes to travel once around the Sun. The closer it is, the less time it takes. A year on Mercury is the same time as 3 Earth months. Pluto's year is 39 Earth years. A day on a planet is how long it takes that planet to rotate on its axis once. As you know, the Earth is 24 hours.
What is speed? We are familiar with miles per hour or kilometres per hour,
But in science we measure it in metres per second.
To do this, we need to mark out the measured distance for the metres and use timers for the seconds.
We need a vehicle and brave drivers who will dice with death down the 30-metre course.
We need a table to record the times.
Workers will tell the timekeepers when to start their timers as the bike crosses the 0 metre zone. They stop their timers as the front wheel crosses their line and try to collect the results.
Go!
I want to ride my bicycle, bicycle, bicycle. I want to ride my bicycle. I want to ride my bike. I want to ride my bicycle. I want to ride it where I like. And all I want to do is ride my bicycle. I want to ride my bicycle, bicycle, bicycle. I want to ride my bicycle. I want to ride my bike. I want to ride my bicycle. I want to ride my bicycle.
We draw graphs of the results and help you to see the different speeds.
To find the average speed, we divide the distance travelled by the total time taken to do this. The answers will be in metres per second.
On your marks, get set.
Louis Pasteur was born on December the 27th, 1822 in Dawn in the region of Jura, France. His discovery that most infectious diseases are caused by germs, known as the germ theory of diseases, is one of the most important in medical history. In 1847, at the age of 26, Pasteur did his first work on patterns in crystals, bringing together the principles of crystallography, chemistry and light. He became famous for other discoveries which we will tell you about.
Jack, it's time to sample the wine.
Monsieur Bigot, this wine tastes like vinegar.
My lord, what am I gonna do? This is my living. We must go and see the Emperor.
Your Excellency, there is something wrong with the wine. It started to taste like vinegar. My mate Jacques shouted.
But I know just the person to solve the problem. His name is Louis Pasteur.
Courier!
Your Excellency, fetch me Louis Pasteur.
Your Excellency. Bonjour. Bonjour.
There is a problem with the wine. It starts to taste like vinegar.
I will see what I can do to help with the problem with the wine, Your Excellency.
After his meeting with the Emperor, Louis worked out some experiments to prove that the wine went bad because of something in the air. He boiled up some broth in flasks, which had gooseneck tubes on top. This sterilised the broth and, as he called, microbes in the air were trapped in the curd so the broth did not go bad. Flasks with straight through tubes had bad broth in them. In this way, he proved that microbes or germs spread in the air. Although he couldn't see the microbes properly like we can, and in particular this rabies virus, Louis' discovery of microbes in the air and his research into diseases has helped us to fight many other diseases. He showed how microbes can spread, so...
Coughs and sneezes spread diseases.
Mummy, I've been bitten by a rabid dog! My papa does that, my poor boy, send him home! What shall I do?
Madame, you must go and see Mr. Louis Pasteur up there.
Monsieur Pasteur?
Oui, madame.
Monsieur Pasteur, you have to help me. My son has been bitten by a rabid dog. I believe you can cure him.
Madame, the experiment is not ready yet, and if I treat the poor boy, he might die.
Monsieur Pasteur, he's going to die anyway.
Okay, you can follow into my house.
Over a period of 14 days, Louis Pasteur's assistants gave Joseph daily injections into his stomach of rabies virus from rabid rabbits' brains. On day 1, the viruses were dead, but by day 14, they injected active rabies viruses. He was not ill because during the time, his white blood cells made antibodies to fight the viruses.
Your Excellency, Louis Pasteur wishes to see you.
Bring him in.
Your Excellency, I would like to have something from the wine producer.
Send in the wine producers.
Bonjour. Bonjour. I have good news, Your Excellency. To cure the wine problem, heat it 55 degrees Celsius, then cool it quickly. This kills enough microbes to stop the wine from spoiling.
Magnifique.
Today, this process called pasteurisation is used to treat milk and beer as well as wine so that we can enjoy our food free from it being spoiled by microbes. Helping to make the film were Manpreet Christopher, Kent Ben, Charlotte Emily, Laurie George, Gafar Victoria, Jade Daniel, Billy Tina, Danielle Chris, Alex Andy, Sonia Sophie and Claire.
This is called a Van de Graaff generator, and it's a machine that generates static electricity. There's a belt inside running around, and the electrical charge that's made by the friction of the belt is collected on the outside of the dome. We can check what the voltage is on the outside of the dome by seeing roughly how long the spark is. For a spark to jump 1 centimetre of air, we need 15,000 volts. So, if we'll put the lights out, please, and we'll see how we go. Oh, that must be something in the region of 4 centimetres long, so we're talking about 60,000 volts. Notice the spark doesn't go from the dome to the wand, it goes from the wand which I'm holding to the dome. And every time there's a shock of electricity across there, it makes it move slightly. Ben's got a fluorescent tube which depends upon discharges of electrical voltage through it to make it work. Let's see what happens when we hold it near to the dome. Wow! The thing lights up. Let's do it in the dark. Here he is. is the original Luke Skywalker. The reason why it's bouncing backwards and forwards is while the charge builds up, it repels the tube. When the charge passes through to Earth, the charge is gone and it comes back in again.
When we stand Danielle up on a wax block and charge her up, her hair pushes away from itself and misses the effect.
Oh, that's fantastic. Oh! Yes. Go on, do it again. Is it coming out on you? Oh, go up to the top. That's the top. That's okay. There we go. That's fantastic. Okay, switch off. Now Danielle's charged up still. Take your hand off the sphere, Danielle. Now to get rid of your charge, shake hands. Oh, there was a nice shot.
Hello, I'm Laurie, and today in science we're going to find out if electricity can pass through things. We put together a circuit to make the bulb light up. When electricity passes through something. We tested plastic, lead, wood and iron. Meanwhile, Kent was thinking about an experiment we did with iron filings. We put some iron filings into a boiling tube and put a bung in it. It behaved like something magnetic and attracted the compass's needle. We strapped the tube with the magnet and found the iron filings lined up. The tube behaved like a magnet. So Manny thought, what happens when electricity goes through iron filings? So Alex put together an experiment to test Manny's idea. He put a wire in a beaker with some iron filings. And connected it up to a ball. We got a crocodile clip and pushed it down to the iron filings to see what would happen. It went brighter when he pushed it down. So Manny thought, what happens to the electricity that the bulb isn't using? Mark put his hands around the beaker and found it was getting warm. So Alex put a thermometer in it and found it was very hot. So Manny thought, how can we measure what's going on here? We can't change what's in the beaker, so George measured the voltage and timed how long it took the temperature to rise. These are the temperatures we got at 1.7 volts, 2.5 volts and 4.5 volts. These are the graphs we got for 1.7 volts, 2.5 volts and 4.5 volts. Our experiment shows that electricity not used in the bulb went to heat the iron filings. Taking part in this film were Sophie Palmer, Claire Service, George Smith, Alex Jackson, Alex Westwood, Charlotte Malkin, Chris Jackson, Manpreet Clare, Michael Newell, Ken Fisher, Laura Garrett, Ben Jackson, after original idea from Alex Jackson.